So we get the free radical. So in case of, you have seen, in case of homolytic fission, the atom which separates attains its own configuration. You must remember, attains its own configuration. Attains its own configuration. This is the homolytic fission. Another way of the fission is heterolytic fission. This is the first fission. Another way of the fission of the covalent bond is called heterolytic fission. In homolytic fission takes place between the two atoms which have same electronegativity. You must remember it. Homolytic fission takes place between the atoms which have covalent bond between them having same electronegativity. That means they have same electronegativity, or they have completely equal electronegativity. Now heterolytic fission. So heterolytic fission, this type of fission takes place in such a way that one fragment takes both the shared electrons, both electrons of the shared pair. Of shared pair. Shared pair में से ये दोनों इलेक्ट्रॉन एक ही को जाते हैं. And other receives none. Other gets none. दूसरे को कुछ नहीं मिलता है. With the result, I will show it here that it is a B-type bond. This is bond pair between the two, but they have different electronegativities. With the result, the bond pair goes to A, while B is devoid of the electrons. With the result, A gets negative charge and B gets positively charged. That is, in case of heterolytic fission, the fragments so formed are electrically charged, or they are having positive or negative charge. That means homolytic fission, this is heterolytic fission. We are studying heterolytic fission. Takes place in the molecules which are polar in nature. The molecules which are polar in nature, there takes place the heterolytic fission. And in heterolytic fission, for example, I will show it here. I will explain that this is CX bond. If this electron pair, that is bond pair, it leaves this organic group and goes with the substituent. That means electron leaves the organic group. Organic group को छोड़ देता है and remains with substituent. So we will get here, I will show it here, X, it will get the electron pair and plus carbon, here it will get the positively charged. So positively charged, here since one valency was satisfied with this X and there are 3 more valencies, that means here are 6 sets of electrons. Carbon having positive charge and 6 sets of electrons. This is formed the carbocation. This is the carbocation. That means in heterolytic fission, I have shown you that this is the bond between C and X. Like C is the organic species, Now organic, this electron pair goes with this X and leaves this organic group, and organic group now it gets positively charged, and already there are 6 electrons, so there are 6 set of electrons and positively charged, so it is carbocation. Now again, if this electron pair, bond pair goes with the organic group, for example, this again I will show it here, this is the electron pair here. If it goes with the carbon, this carbon, the species will be C. Electron pair here, negative charge, I will show you 3 valency here, and plus X will get positively charged. Now this negatively charged carbon now having 2 to 4 to 6, 8 electrons, that's complete octet, and having negative charge is called the carboanion. So we came to conclusion that in homolytic fission results the formation of free radicals, and heterolytic fission results in the formation of carbocation and carboanion. In carbocation there is 6 set of electrons and positive charge, and in carboanion there is negative charge and 8 electrons. So now we will come in the homolytic fission again, how homolytic fission takes place. We have seen you that in case of homolytic fission, free radicals are formed. So first of all, we will define what is a free radical. A free radical, I will define it, an atom or a group of atoms or organic species having odd electron, or we call it unpaired electron, this is the definition of free radical: an atom or a group of atoms or organic species having odd electron or unpaired electron. This is formed by the homolytic fission. This is formed by the homolytic fission. Formed by homolytic fission of covalent bond. This is formed by the homolytic fission of covalent bond, and it is electrically neutral. It's electrically neutral. Now, I will show it. You know this. These are formed from. This is formed by the initiated by the energy and formed the vapor phase. Formed the most common mode of fission of the homolytic fission is in vapor phase. For example, I will show chlorine. Chlorine. Here we get Cl free radical or the Cl free radical. Now 102 calories of energy are used. Sorry, here ultraviolet light is used. Again, if we take CH3H, I have shown methane actually. CH3H is methane. When fission takes place, it gives methyl free radical plus hydrogen having an odd electron, that's free radical. So here it takes 102 kilocalories of energy are used. So in case of, for example, I will show this is actually ethane, and when the one of the bond breaks, we will get CH3, CH2. Here one electron bond breaks, ethyl free radical, 97 kilocalories of energy are used. So we know that energy is used in the formation of this free radicals. Formation takes place either in presence of the ultraviolet light, as in chlorine, or energy is used. So now, what are the characteristics of the free radicals? We will explain what are the characteristics of free radicals. You know it. First characteristics, you know, free radicals are electrically neutral. First, free radicals are electrically neutral. Number second, they are unstable